Hello, good evening, everyone. I'm starting our first content webinar. We will have several content webinars. This one will be about regression and classification models, as said earlier. But next week we'll have one about evaluation metrics for your models, which is a rather complex topic. I hope I can show in an easier way, but throughout the week, I hope I can send you guys some links so you can read something in advance. So when you get to the presentation, you'll be a little more familiar. But yes, that's for next week. So let's focus on this week, which is regression and classification models. So let's start with a brief presentation. I'll make a big presentation using PowerPoint, and then we do some live coding. So let's begin. Yep, I'm sharing my screen right now. Let's open. Here we go. Here we go. And let's kick off the presentation. Okay, classification and regression models. So what are these models? These are models to solve two of the most common machine learning problems, which is regression and classification. For each of them, we use a different type of model. Could be classification, you use a classification model, of course, and regression, you use a regression model. There are many models available to classification, many models available to regression too. So you can look through a sklearn, especially the documentation. They have a fairly good documentation on each model. And yeah, you may choose the one that better fits your needs. I mean, for some tasks, uh, the let's say decision trees, which I'm sure you all have been using this past week, following lesson 4, if I'm not mistaken, the lesson on decision trees. For some tasks, it will be better. For other tasks, support active machines will perform better, and that's it. So let's start with regression. Let's focus on regression. We do some coaching, and then we go back and talk about classification, shall we? So, what is regression? Regression consists on predicting the value of a function or a process uh, based on the characteristics of the observed sample. I mean, we're talking about specifically about supervised learning because is the session you all have been going through right now. So, what is the common models used to do this task would be linear regression. It is the simplest machine learning algorithm. I mean, it just fits a linear line through a function. In the regression trees, yes, trees also do regression. So you have the regression classifier, which I believe you've been using to implement the Titanic quiz on the decision trees lesson. And we also have polynomial regression when you have to fit, uh, we have a polynomial function and you want to fit a line that to the samples. So let's take a look. See here. Here is the simple linear regression, the simplest way. Here you can see y equals a times x plus b, which would be a linear function. Would be this blue line you guys are seeing on your screen right now, the regression line. The way we fit this, we minimize the minimum square error, which is the distance between the samples. Each black dot is a sample. The distance between the samples, we try to, in the line, we try to minimize them. But as you can see, you're not going to get a perfect line. You can get a perfect line through the samples. They all have some variance. And we try to fit this line in the best way to describe the function or the process. For example, let's say you're trying to predict the house price based on the on the size of the house. So we try to fit uh, A would be the size of the house multiplied by the x, which is the coefficient you will be no, I'm sorry. A would be the coefficient you have learned through fitting your model, and x would be the price of the given house, the size of the given house, plus some sort of arrow, some sort of coefficient that you also will learn through the model. And y will be the predicted price. For example, let's say you have a house of size of 10 square feet, which would be a very tiny house, of course, but let's just go with that. So you projected the house is 100, so that will be multiplying 10 times the A, whatever it may be, plus B would be equals to 100 if you were to predict it. Your model was to predict that the price is 100. And this is the kind of process you do with the regression model. Regression model, you will try to predict some values. Okay, so here's the simple linear regression. Now I have polynomial regression, which is in this case you can see there is a square function a times x squared plus b times x plus c. A, b, and c are the coefficients that your model will be learning through the training process, the process of trying to minimize the distance between the blue dots in this case and the red line. The red line will be the where your predictions may lie. So I don't know what kind of function we have here, but for example, for the one here, value one on the x-axis, we are predicting somewhere between 2 and 4, or say somewhere between 3, yeah, be predicting about 3 for this when you have the variable x. So imagine again, was the house example, it will, and the size would be equal to 1, whatever the unit it may be. And you replace 1 in this function that we just learned. A, B, and are in the term C, of course, will come to a cost of 3 that we can see here. So you'll be projecting the price of 3. So whatever unit may be, I mean, I'm not talking about units. Maybe it could be thousands. It could be you could be talking about tens of, I mean, hundreds of feet here, and thousands of even millions of dollars on the y-axis. But you may be wondering why the points will never fit exactly on the line. That's because in every model, doesn't matter how good your model is, you have some unpredictable variables that will affect the price of the price of the value of your prediction. For example, if you look at one of these blue points on the upper corner that's above the line, your model would predict that somewhere below the actual value of the said house. Why is that? Well, because your model has no way. Maybe you did not encode something like the location of the house. So some houses of the same size in different neighborhoods would cost, different prices, and maybe the state of the house, how the house is when the house was built. Um, Maybe it has a very nice backyard, so it will cost more. It will, and your models will not predict that. So, and the same things would be true for the points below the line. Maybe the house is not in a very good condition. Uh, Maybe the neighborhood's not nice. I mean, you could be using neighborhood and so on, but you never will be encoding every single variable of the real life of a real life situation. Uh, you cannot do that. I mean, it's possible for any model, but nevertheless, the estimation would be very good. I mean, you can see this line, you can see the the predicted value is not that far away from the actual value, and the error is to be expected in any situation. So any model you predict, you're never going to predict uh, the exact value, and that's okay. That's is expected. So that's the use case. Predict the values, continuous or not. I mean, I'll talk about why not always continuous. For example, predict the value of house based on its location, size, number of rooms, school nearby, crime rate of the neighborhoods, and so on. These would be the variables of the each sample that you'll be using to train your model with respect to the price of the house. Location, size, number of rooms, and so on would be the variables now that I'm just talked about. What else? Predicting the pressure inside an object based on the water content inside. I mean, when you heat a closed object with some liquid or even air inside, the fluid will expand, and that will increase the pressure inside the said object, and that's it. That's what uh, you could train a model, even though you may not know the function, how the pressure vary. Your function, your training model will learn can be trained to learn that function without you not maybe you're not even able to model the exact function through mathematical modeling, but yeah, but uh, fitting the real case will actually result in a fairly good prediction. What else? Predicting the number of bacteria on a sample, and you see that will not be continuous. That be numbers 1, 2, 3. Won't have 0.4 bacteria or something like that. And based on the availability of food and time, I mean, would be two variables that probably could you be used to predict the content of bacteria on a sample. And that's it. Now let's go for some coding. Okay, everybody, still with me? Okay. Okay, everybody can see my screen. So let's start with the coding, shall we? Let me move this out of the way. Some of you have been have had some problems and make some questions about how to better use Jupyter Notebook, how to better load data in Python, and so on, how to get data sets. So I'll be going through two problems, one for classification and one for regression. Right now, I'm going to start with regression. And this is how you get data. For example, for these problems, I was looking for some data sets, some toy data sets that I could use to demonstrate to you guys how how these problems work, how you solve these problems. And I did go to UCI. This is the UCI machine learning repository. Let's go here, UCI. See, here we have some very good data sets. And the first data set, I believe, would be a noise data set. So let's go here. For you. Oh, there. Yeah, here. Here. This data set from the UCI. The reason why I choose this data set is because it is a problem I have worked before, and you allow me to demonstrate to you some important concepts, concepts that will actually be used in your first project. So be sure to pay attention to that. And what you do is you go to this data folder, and here is the data set. I'm gonna take a look at it. So here how the data is presented. Uh, to use this data set, I had to do some transformation. I mean, simple transformation. I could not load this data set on this format on Python, so I did open it using R, the R programming language, and then I saved it on a CVS file. I transformed it into a CVS file, and I'm gonna load the CVS file. I mean, when you're dealing with data, you may need to transform your data, clean your data before, so that's a completely separate subject, and that requires a different approach for each problem. So it's not something I can really show you how to do for every project. I mean, you have to uh, get into the culture of looking how to do that, looking online. I mean, you can find some really good content on Stack Overflow, people posting how they did it, how they ran into this problem before, how they solved it. And here we have this data set. I mean, I've already downloaded the data set. So anyway, we're good. Save link has and download data set to something that you can load. But I already done that, and I'm gonna share this data set with you guys later. But I picked this data set, and now let's open the Jupyter Notebook. As you can see, I'm on a Mac, but it's the same thing around Windows, the same thing with Linux. You go to the Anaconda Navigator, wait for it to open. Loading some applications. And here we have the Jupyter Notebook. If I just click launch, it will open the terminal and will launch. It looks like a web page. It's not. This is not a web page. This is the code editor. I'm gonna navigate. I'm gonna go to the desktop. I'm gonna go to the Udacity mentorship. Here's the folders I created a few hours ago, so I could keep everything present it to you and then send it to you later. And I'm starting with regression. I have already put the data set here. Is this the CSV file? I'm gonna click on new, and I'm gonna click on Python 3, and I have started a new notebook, and I can start programming. So I'm gonna rename this file. Name it classification. Oh no, I'm sorry. Solution. And here we go. There is another way of opening the Jupyter Notebook environment. So let's say I close this. I'm gonna leave the page. And I'm gonna close the Jupyter. I'm gonna close this terminal. This terminal has to be kept open and has to be running for your notebook to function. Now I stop the notebook completely. My notebook won't function anymore until I launch it again. or I open it in some other way. But I'm gonna show you guys how to open, how I usually open. I don't usually quit. Okay, quit. I don't usually go to the navigator. I usually go. I open a terminal window. As you can see, just a terminal on my computer. I just type it in the notebook. Now it's open. And I can do that again. I can go navigate to the desktop. I can navigate to the same folder I was before, regression, and I had already opened and saved that notebook you were looking, and I just gonna open. So there's no code inside. Let's start programming. So first thing first, let's load Visual pandas. Should deal with datasets, and I always load NumPy because we may need, maybe we won't need, but let's keep it in. And I'm gonna hold Shift, press Enter, and I'm executed the cell, and this cell was executed, so I loaded pandas and NumPy, and I'm gonna start loading the dataset. I'm gonna call data frame, and I'm gonna go PD, which has a nickname the pandas. That's why I always keep PG, because otherwise I will have to be typing pandas, and it can get quite tiring sometimes, can tiresome. And I'm gonna use the method read CSV. This should be pretty familiar to you. Enable datasets noise, as you can see, and I'm on the same folder. Otherwise, I'll have to use some navigation like Regression folder. That's why I always keep it on my always keep the dataset on the same folder I'm doing. But you guys are free to try it any other way you find interesting. So data framing, let's done. It's loaded. Let's look at the. Always look here. You always look at the data, do some exploration. Let's go back to the UCI repository. Here we have the documentation of the dataset, which each app variable works. So I can see this strange variable. That's because I forgot to drop the index that I use in R. So this column I have to drop it. I have to remove it somehow. I'm gonna do it right now. The column is named. Oh, no, the coolest thing about Panda, about the Jupyter Notebook, if you hold Shift and you hold down the Shift key and press Tab twice, I have access to the signature of the function, so I know what I should take. It takes labels, axis. You have to refer to the documentation, complete the pandas documentation. You can find that documentation on Google, so you can know which the documentation of the method. But here's a quick way of looking at the signature. Maybe you already did go through the documentation, you know what you're gonna use, but you forgot that columns, for example, should be named columns and not something like call, for example, not an abbreviation. And you want to look the naming scheme. So it's a quick way of getting access to the signature method. I think I find it quite useful. Sometimes I do forget how I should name everything on the function. So x equals 1 means that I'm going to drop a column. And I also have this in place, I believe. Place, yes. Which means I'm gonna remove from this data set, and I'm gonna completely remove it. I'm gonna remove in place. I'm not gonna remove from another data set. Maybe if I was doing something like, I would not need the in place, but I'm gonna use the in place, and now I'm gonna add another variable. So in place equals true. See, now we got rid of that. So let's go again to the CY. So here are the information on the attributes. One thing to go to look through is if the data set has some no values, you should do that in pandas using snap method. I mean, you can look that online how to count any this any values. But for this data set, I have already went through and it has no any values, so we should be fine. So now that we have that, we know that we want to predict the noise. The noise is the V6 variable. I'm not going to spend time renaming the columns because we're losing a lot of time and we have to use our time carefully. So let's get the features. Data. Here I'm using the same method. I'm gonna make a copy of the data frame, but I'm gonna remove the v6 variable. Then it is what we want to predict, which is air pressure or the noise. In place it goes false because this time we're actually sending to another variable, so there's no point in having it in place. Plus we're gonna use it later, this variable later, and cannot simple delete this variable. So I'm going to do the same thing to get the target. There's a typo here. Sorry. I'm going to get just the V6 variable, which is my target. Oops. What's the error? V6 was not found. V6 not found. Okay, let's do it again. Yeah. 6 variable is here. Here's not. Let's comment lines in. Oh, it's not finding the V6. That is strange. Maybe if I just I think it worked now. That's normal. And let's look at the, everything looks fine. I was not expecting that, so you guys know. It's fine for the features. And it's good for the target. So now we can start with the machine learning processing. First, we're going to divide it into training and testing sample data sets. So we're going to get sklearn model selection import training test split. How I know how to import this? It's pretty simple. I go to escape. You just always go to the scikit-learn documentation. I mean, this is your best friend from now on. It's really helpful. Maybe you want to do something and you go to Stack Overflow. They say this method, and you go to this all the parameters you're gonna take. This function takes, and we have even sample code. The sample code works, so it's really nice to have this, and you can even reverse engineer this code, maybe to your problem, and it's really nice to have these samples. I mean, it's really helpful. Let's go back to our problem. Train test split, and we do this x train test. This is the same thing you have been doing on your lessons, so don't worry. It's the same thing on the quiz about the Titanic, and the lesson about trees, about decision trees. Equals train test. Let's go. Haven't loaded. It's a features. Target. The test size. I'm gonna use 0.2. I'm gonna use 20% of this data set to test, and you always set the random stage, because the range is random stage. You're always gonna use it because it allows you to redo the same test. I mean, if I use, as long as I use 22 as a random stage, I'm gonna always get the same randomness on choosing which variable is a test variable and which variable is a train variable, which sample is a train sample actually. So it would be the same for two. In the important thing is when you wanna redo the test, you always use the same number. I'm not using 22 just because there's no point in choosing another one that could easily use for two. As long as I keep the same, I'll always get the same random stage. Yeah. Ah. Of course I don't have. So here I have my train. training, and let's try using a model to do some regression. So we have true regression, we have could try linear regression, which I don't think would be fine. Don't think would be too good for this data set when you look at the how the function it behaves. I don't really think a linear model will fit this process very well, because I have plotted this before, I have worked on this problem before, and it does not work. So instead of using I'm gonna try something really nice for you guys, which is scalar. We're gonna use a neural net. We're gonna use a neural network for doing the regression. It's a very simple neural network. The activation function is going to be the ReLU function. This is something you're going to learn on your next section, so don't worry if you don't get what a neural network is yet, but it's a really nice model. And it can do regression. And if I could use the procedure to classify, I was gonna get the classification, and once again how you get the name of these things. I'm using, you go through the documentation, and you're gonna have to go, and like I said, it's really helpful to get used to going through the documentation. I'm gonna instantiate one of these regressors. I'm gonna call it MLP regression. I'm gonna set the hidden layers. Actually, let's do this. I'm gonna have to go to here. Looking at the documentation here, I have the hidden layer size. I'm gonna copy and paste this there. The usual activation function will be the ReLU. Adam will be the way of learning the optimization function. It's not gonna be gradient descent, although we could use the gradient descent here, but it doesn't make too much of a difference. Here, SGD, essential stochastic gradient descent. You're gonna learn that in the next your next session, so don't worry about that. I'm just going through a quick overview just so you guys get a taste of what's to come. When I could have used a tree, but what's the fun in that, right? I'm gonna use 500 just because I can. Why not? I'm gonna use the fit method again. What are the methods I'm gonna have to use to fit? So the fit method, which takes the x and the y, and it fits the model. I'm gonna get a prediction. Here I'm following on the question somebody made a few days ago. Here I'm using the method to do the predictions. and I'm gonna predict everything, all the samples that was selected to the test sample. So I'm gonna test it. And what it does is it iterates over all of the training of the test. I'm sorry. Damn it. I have no. Fine. I'm sorry. Yes. I had a lapse right now. So okay. So it's going to iterate through all the X tests, the 20% of the samples that were actually selected for the testing. I'm going to generate a vector of predictions, one prediction for each one of them. And let's run this. It ran. Seems to be fine. So let's plot this and look how we're doing. Okay. I'm going to import matplotlib, which is a plotting library. Um, I'm gonna set the field size. I mean, you can, once again, you can find this. I did find this options on Stack Overflow. I was looking how can I make this graph bigger, and this is how. It did not come out of my head, so you guys know. I'm gonna limit the axis just so I'm gonna plot, since I'm gonna use two plots, I'm gonna link the axis to so they all will fall on the same the axis will be together. It is necessary if you want to these numbers is because I did go through and the minimum value and the maximum value is 0 and the is the number of maximum distant maximum number of samples we have. I mean, we actually have a little less, so but I did set because I didn't want to run out of space. This is just fixing the axis, so we don't have a X problem. I'm explaining the predictions. Now what I'm gonna do? Okay. I think I have to do something else here. I'm gonna have to come here. Say cell below. This is because and this is standard Python code. This is because we have a problem with the index of the white train because they are shuffled, and I have a problem plotting that. So I'm gonna call them Y original, but I'm just taking the same everything that's inside this Y test object, and I'm just copying to a new vector because I want to reset the index, and I have a problem plotting. So these objects, these elements, are the same elements inside this. So okay, Y original, and set the color to green. I'm gonna do this and just copy this. I can't believe that. Sorry. Well, guys, I'm sorry. I cannot plot anything because of this dim function. Apparently, I'm gonna have to fix my Python installation. Yeah, I'm gonna have to fix my Python installation. See what's wrong. Was working just fine. I'm really sorry about that. But I was gonna plot this, but no worries. We will be fine. We just go to the next problem, which is not the regression. We're gonna use the damn it. Start Python here. Yes, the same problem. I'm gonna install the Python. But right now we're fine. We did everything and we pretty much solved the problem. I was gonna show you how to do this other thing that I was doing earlier today, which is scaling. You should always scale your function. You would see that it will not work so well. Instantiate scaler. It worked. I hope so. It worked. So what I did here was to scale the function. values, because if you look here, I'm gonna print they have very different, each variable has very different values. For example, this is 100, this is 0.002, and this value will dominate over this value because they are so much larger. So what we do is we scale, use this scaler, and this is what I did here. So we will scale the training variables, the feature variables, which is this here, and you get it all scaled before you train. I was gonna show you this, but I have this problem with matplotlib. I'm gonna install my Python once again. I'm truly sorry about that. If you guys have any problem with that, let me know. But I'm gonna send this whole code to you so you can run, you can tinker with it, you can play as much as you want, you can reverse engineer it. So I'm gonna finish this regression part here, and we're gonna go back to the classification problems. And let's go back. Now we have to go a little bit faster here because we lost a lot of time doing the coaching. Here we have logistic regression. These are the models for classification. Classification consists on predicting the class and grouping together similar objects, similar samples. Like in this, for example, here is a support vector machine. We group together the red samples and the blue samples based on their characteristics. For example, the Titanic that you guys did on the decision trees lecture. It is a classification problem. What you guys gonna do in future lessons, like the image classifier is a classification problem. Of course, it's called classifier. The credit card fraud. And once again, we'd like to do some coding, but I think we are out of time. So I'm gonna do instead is I'm gonna get the code that I have already written somewhere. We are truly out of time. I'm sorry about that. I'm gonna go to my Google folder. It's not here yet. I'm transferring some file from my other computer. Here it is. This is the complete code. We already did the process of opening the filter notebook and so on, so I don't believe it will be necessary to do that again. I'm just opening the another notebook, and here I'm using the iris dataset. It will be available to you. I'm doing the same thing. I'm not gonna replace anything. I don't know why I have this here. This is the one of the most common. What are the slides doing? The first one is renaming the columns because when they come to the data sets, they don't have a useful name in the columns. So I took the time to rename them. I'm loading the ICE data. This is actually a CSV file, but it has this data termination, so I just have to write it that. But it is a CSV file. I'm gonna send it to you. This is the one of the most famous datasets. Is the beginning for the toy dataset, which contains samples of three types of of plants. The first one, Setosa, Virginica, Versicolor. It's 50 samples for each, so it's a balanced data set. It's quite balanced. 50 for each target. And what we're gonna do is gonna use a classifier. We're gonna do the same thing. It's useful to look at the features. We have 4 features. They are all numeric, and there's no one is missing. Nothing is missing. So take your time to go to the IDs. Look for IDs here. Here on Wikipedia, we have a complete description of the dataset, how it came to be, why is it important. We have some plotting of the data. And I'm gonna use, I'm gonna split. I'm gonna import the decision tree. Here we're gonna use a decision tree. I'm gonna fit the decision tree. I'm gonna predict the decision tree. I'm gonna look at one of the predictions. I'm gonna look at one of the samples. It is a Virginica. Just be sure everything is okay. I'm looking at this. I'm gonna use a look at the. I'm gonna load another classifier with the support vector machine, the SPC, which is the support vector classifier. I'm gonna instantiate this. I'm fitting it again. It's just some warning about idiot load, so just something I have to change in the future versions of my code, so don't worry. I'm gonna predict. I'm gonna load the accuracy, and here you can see that the accuracy for the machine is actually bigger. The machine is actually better than the tree for this split that I did. It's something I want to show. These classifiers, they have different performances. In this case, the support vector machine is actually better, a little bit better. So I'm gonna send you guys this code, and from the coding part, I guess we're done. We are also done with the presentation, I guess. Yes, I'm done with the presentation. And something else I want to show you before ending this webinar. I'm finishing the Jupyter notebook. Something else I'm gonna show you is I did say I was gonna show you a tree, and I am gonna show you a tree. We actually are gonna visualize a tree, a decision tree, on the train it on the IGES dataset, which you can see is a simple dataset, so you can perform a useful visualization. But I have this tool which is called Orange. You guys can install it using this Panda Navigator, this Anaconda Navigator. Just have will be written install. You just install it, and there you go. This is just a tool for learning. So you see, just grab the dataset, just drag and drop, drag. I'm gonna double click. I'm gonna use the iris. I'm gonna send data, and which means I'm gonna load this data. I just load the same dataset we're using, and I'm gonna use something, a model, which is gonna be the decision tree. I'm gonna link the decision tree, and now I have trained the decision tree. I'm gonna use a visualizer, tree viewer, and here we go. This is a decision tree. You see, we start with all the samples grouped together. On the first separation, we can classify all the Setosa samples, just split them all. You can see that they don't continue down this tree. And now we only have the IDs, all the 50 ID samples, the 50 Virginica samples, and the 50 versicolor samples. So here we divide a lot of the Virginica, but as you can see, in the end we mix a few of the samples. We're gonna get mixed. It's not possible to separate completely all of the samples. And this is a decision tree. This is it visualized this as I said before, because this is a simple problem. It's a toy data set. We can actually produce a useful visualization. But if it was the case, we only have hundreds and hundreds and hundreds of variables. It is not useful to visualize the tree, because it will be such an enormous tree that we have no use for trying to visualize it. So with this, we conclude this uh, this webinar. I would like to thank you all for coming. I'd like to thank you all for watching. And once again, I'm sorry for the visualization I was gonna produce with Matplotlib, but I'm gonna look through my Python installation and probably gonna install Python and install the Matplotlib, see what's going on, what is the problem. But it will take too long to do this live for you. I'm gonna quit Orange. Uh, Actually, no. Let's just if you guys want to download Orange, it is on the Anaconda navigator. So you just go to the navigator, and it's gonna have this. We're gonna be green like install, and just install and you launch it. And then again, new, and here's here we have the data. We're gonna load the data sets from here, and there's more than the iris data set. There are another toy data sets that you can use to play. And here we have SVMs. We also have linear regression. We have logistic regression. Logistic regression is not a regression model, it's actually a classification model. See, classification is written, it's written here. So there's another classifier. We have random trees, random forest, I'm sorry, naive Bayes, and you guys can, neural nets even, and you guys can look and play with this. It is a good learning tool for you guys to play with. If you are having problem comprehending anything, you can try this. You have rock analysis, but I'm not using this. Unsupervised learning you're gonna use on the a few lessons ahead of, you have it a few lessons ahead. So if you want to keep this tool, this is a nice tool to have, especially when you're learning. And that's pretty much it. I would like to thank you all, and I'm gonna go back here. I'm gonna stop sharing and I'm gonna go back here. So yeah, thank you all for coming. I wish you all a very good week, and I hope you guys can. If you have any question, please contact me. I mean, this webinar is gone way too long right now, but a few of these techniques that I've shown you, you're gonna be using on the first project. Probably gonna be using the scaling function to scale features. You'll see how that is done. The min max scaler. And once again, I'm sorry for the Python, for the matplotlib problem. I'm gonna reinstall Python, see how it goes. It was doing fine a few hours back, but yeah, you never know. I'm just gonna reinstall Python, and one way or another on the future webinars it will be working. Don't worry. So that's it. Thank you all for watching. Have a great week. Any questions, you may come to me anytime. And we finish here. Bye bye.